So hello, my name is Guy Corland. I'm the CTO of Incubations in Redis Labs. Most of what we are doing is building new modules. One of them is what we are doing with Luca from TensorWorks. We are building together the Redis AI. I would like to cover what was the path that we went in Redis Lab. We started about 2 to 3 years ago with Redis ML. That was the first module that we released that has something to do with machine learning. And it was kind of successful. People liked it, people use it. It kind of solved a problem that many people felt like ML is not solving. Meaning you could have train your model using Spark. You can develop your own model. Again, I'm not talking about deep learning model. I'm talking about old-fashioned models, regressions, random trees, and stuff like that. But once you wanted to deploy it in production, then new problems started to arise. And the bigger your model was, the bigger the problem were, and you needed to think about DevOps and how you're going to deploy it in production. How you going to make it scale? How you going to make it not too expensive, because you still need to move the data between the model and back. And from that, Redis ML arose as a solution for that. So it was a kind of a cooperation with the guys from Spark, from Confluent. The idea was not from DataStack. The idea was that you can train your model with Spark in a distributed way. You can train a very nice model. Again, not a deep learning model, because deep learning was not that strong back then. And then you can use this model and deploy it on Redis. In that way, you got a way to co-locate the data and the model. So this way you could reduce the latency between the data and the model. And you could have used any client, Redis client. So if you are familiar with Redis clients from different languages, you could have accessed this model, ask it to classify the data, and it worked. And we even got some real-life customers or users using it. For example, for recommendation. For example, in this case, they did some movie recommendation. They trained the model, and then they classify the data using Redis and recommended the right video to the right user. And obviously, performance was much better because we reduced the latency between the data and the model. If the standard way to do it was to use Spark to classify your data using Spark, and what Spark does behind the scene is retrieving the data, loading it into Spark, classify it, and returning the result. In our case, you didn't need to move the data. The data resides on the same process in the same exact memory where the model was. So as I said, we supported in Redis ML different models, the different models that Spark usually supported too. But we were missing something. We didn't support neural network, and in the last 3 years, as you know, there is a big boom of neural network, a large set of new tasks, a new problem that you can solve with neural network that we couldn't solve with Redis ML. And for that, we needed a new solution. And we thought about how to extend it. And instead of implementing the algorithm like we've done with Redis ML, we thought the nice idea or the good idea here is to adopt the already common engines like TensorFlow or PyTorch and adopt them and provide exactly the similar solution. So instead of now serving linear regression or random forest or random tree, we're now being able to serve deep learning model. And for that, we partnered with TensorWorks and with Luca, who developed this model as I would say, side project at the beginning, right? It was called Redis TF for TensorFlow. And together we built this Redis AI, and I think Luca can present it better than me. Luca, thank you.
Thank you.
There you go. Oops.
There'll be no audio this time. Okay. So I'm going to describe Redis AI, why there is Redis AI, what it does right now, and what it will do in the future. So this talk will cover something that I haven't covered yesterday for whoever was there. And if I play it, it works. Okay. So this is the dorky sentence. Don't say AI until you productionize, because there are many proof of concepts, but what happens if you then like your model, you have your image classification model, your chatbot, your language model, and so on, or anomaly detection in industrial use cases, what do you do to put it in production in a way that it's reliable, fault tolerant, and so on? And of course, we want to build on our expertise, on the expertise that DevOps people, developers have accumulated over the years using technology like Redis. So how can we leverage that and use that experience to take AI into production? And so the focus on developers is what my company, TensorWork, is obsessed with. So in an era where software can be written top-down or can be written using data, examples, this is becoming increasingly something in the domain of developers. From data science is going into the development side of things. So our mission is to bring development tools to the new era of developments, of software development with data as a source code, essentially. Okay, so it's going to be developers. Deep learning frameworks. The choice of deep learning frameworks shouldn't really impact what you do with deployment. So there are two main deep learning frameworks right now, TensorFlow and PyTorch. There are others. They're really, MXNet is very used. So how do we take this, feed it with data under the form of tensors, train it, and this is outside the scope of Redis AI. But once we train it, how do we deploy it in an environment that can scale from close to sensor data where data is generated, or on large cloud deployments with certain reliability guarantees? And how do we do that, and how do we develop application against those neural networks that are deployed in the wild in a uniform way, independently from deep learning frameworks? And there are a few approaches that are used at this moment in time. One is ask the code from the data scientist, stick it into the container, write a Flask server in front of it, and hope for the best. And of course, you can massage it a little bit. But this is good if you know what you're doing. And but of course, it's challenging to provide the same set of guarantees that you would have by using a highly available store like Redis. You can use an execution service from a cloud provider, or you can now there's the rise of runtimes, like TensorFlow Serving is the most notable one. There are others. There's one from NVIDIA and so on. The MXNet model server by Amazon. These are all projects that are used to put AI in production by, you export your model, you run it there, and they expose a REST or gRPC interface in front. Still, this is not an object that people know operationally. So it's a new tool. It's something that you have to learn. What we want, or what we want to avoid, is to have Greg come into our stack, right? So I say, oh no, now how do we fit this? Wouldn't it be great if everything just fit and operate uniformly? So keep the stack short and use something that you already know how to use. So this is what we try to do with what we're trying to do with Redis AI. What it is, it's a Redis module provided tensor as a data type. You know, Redis has a lot of data types. With Redis AI tensors, so with multidimensional arrays of numbers, matrices, 3D matrices, 4D, whatever a neural network needs is a data type. Then an execution or one or more execution engines for deep learning workloads that work on CPU and GPU. So it really turns Redis into a full-fledged deep learning runtime while still being Redis. So while having the same operational characteristics as Redis. So I showed this in the keynote. Redis now talks tensors. You can install PyTorch and TensorFlow graphs in it. So you set them at a key. We'll see how to do it in a minute. It will support machine learning models in ONNX-ML format. So you will be able to run random forest, support vector machine, and train them from scikit-learn, for example. So you train a model from scikit-learn, export it in ONNX-ML, stick it into Redis, and run it on whatever infrastructure you have with Redis operating. And deep learning networks will be able to run on CPU or GPU. You will be able to choose, or you are already able to choose. And then there is TorchScript, which is a great component that we take from the PyTorch backend that allows you to specify operations on tensor. So you have a giant standard library for tensor operations on CPU and GPU that you can run without even touching those frameworks. Just Redis understands it and will run it. And there are use cases for that, and you can do it in a distributed fashion as well. So we will run with replication rather than distributed. So this is the internal, what happens when you submit a script or a model. It puts it in a queue, so there's a back pressure mechanism within Redis that will manage the queue internally. So this means that you don't need to have more components with distributed queues that manage running the graph, because running a graph or a model is an expensive operation. So you want to control how many of them are running at the same time. You can't just throw calculations like that. So it manages a queue. It will manage one queue per device in the near future. So you will have one queue per CPU, one queue per GPU, 0, 1, 2, 3. And then it collects, and everything runs in a parallel thread. So while it's executing, of course, Redis is available for responding to get tensor, set tensor, and so on commands. You can get it this way. There's a Docker container. There will be a Docker container with GPU that is enabled with the GPU. This is a CPU only, but it's really one command away. This is repo. It's being developed in the open, so feel free to go there. This is the API. You set a tensor. I showed it in the keynote briefly. This is a key, the data type, the shape, and you can stick a blob of things. Of course, in a programming language, it's just an array of unsigned integers. It's a byte, and you can get it back. This is the data structure behind it, for those of you who understand C. It's really light. So we use DLPack, which is an interchange representation for tensors. It's something that was already developed to make several frameworks talk to each other, and we adopted it for Redis AI. So this is the data structure that where Redis AI unpacks things and keeps them in memory. And it already supports representing those things in on the GPU directly. And then you have a model, you train it, you export it, and we'll see in a minute how to do it. And this is how you set it. You decide what the key is. You specify what the backend is. Right now, it's PyTorch and TensorFlow. In the future, there will be more. But we want to have a steady pace. Like, we don't want to rush things out too much. The device where it should go. And then we have, this is the only difference between PyTorch and TensorFlow. So the only difference is here in the way you set the model, because TensorFlow also wants the name of the nodes in this graph, how the input and outputs are named as in the computation graph. So you have to know, and we'll build facilities to get this information in an easy way. Well, PyTorch doesn't need it, but once this is done, then whatever model you have, PyTorch and TensorFlow, you always run it using the same command. So you don't have to change your application if you want to switch from TensorFlow to PyTorch. Only the set of the model that happens when you actually set the model. You can set it on the same key, and your application will continue working against a model that is implemented in another framework. So this is convenient. And these are keys. So ResNet and Foo and Bar are all keys. So you set this tensor in Redis, you set this model in Redis, and end up asking it for what device to use. And this command will run this model on that device using this as an input and creating a tensor as an output. This is how you export for TensorFlow. I don't know how many of you are accustomed with this code. We have an extensive repository with examples, so you can go up there, and there's also the model saving part. But essentially, you load a model that is assumed to be already there in the form of a session. You get the session, and then you convert the variables to constants, and then the so-called frozen graph in a protocol buffer file. And this is the file that you want to save. And for PyTorch, it's really similar. You trace the model. There are different mechanisms. Keras, you can do it from Keras. TensorFlow 2 is something we'll support in the near future. And then you have, again, a protocol buffer that you can install into Redis. Script, as I was telling you, Redis AI gives you the possibility of having a Python. It's not Python running in Redis AI. It's libtorch, the backend in PyTorch, that has an interpreter for this language that looks like Python, but it's dedicated to tensor operations. So it feels like Python, it looks like Python, but it doesn't require Python interpreter. So it's very high performance to run things in here. And effectively, if you install this on the GPU, it will run on the GPU. So the addition will be performed on the GPU. Okay? And it's the same thing. You set the script, you choose the device, you set the text file with the script in it, and then you can run the script, key of the script, name of the function within the script, input tensor, output tensor. Really, really simple. So we already talked about that. Typically, this is an example of a more complicated pipeline you may want to use. You get the input tensor in a raw format, like an image. You want to resize it or normalize it for your model. You can do it in script directly on the GPU. And then you want to run a couple of models because you want to ensemble them. So you take the probabilities, you want to average them. So to gain robustness in your prediction, you can do that with script. You do the average, and you run the two models. You set them in two different keys, and you can run them and get the output. Persistence. Now we get into the Redis-like features, right? Typical Redis features. RDB is fully supported, so you can persist. Everything is persisted natively, so you can resave the models in protocol buff within the RDB file. Tensors are serialized as they are with the buffer, and scripts as a text. AOF is there. It's deactivated at this point because Redis cannot deserialize an AOF file if the command is blocking. It's a technical thing that will be fixed shortly. But you can consider it there. It's not there if you go there now. Okay, but it's gonna. Replication. Replication is already there. So you can do master replica topology. When you set a tensor, it will be replicated. When you set a model, it will be replicated. And so the only problem right now that after conf we will fix, it's nothing fundamental, but the time was kind of missing, is that the commands are replicated. So if you say model run, that command will run on all the replicas. But we just really want to replicate the results, right? So we want to do that, and we will do it shortly. But replication already works. Cluster works, although it's a bit tricky because you have to ensure that all the models and the input keys, all the input tensors, all on the same node. So there's no automatic, like Salvatore was talking about this morning. We're looking for a good solution for that. to make it easier to use cluster. Client libraries. Any Redis client works. So any language that supports the Redis client, which is virtually all of them, supports an execute command or a run or whatever call, and you can use the Redis AI commands on that. But we are developing with the Redis Labs team a number of clients. JRedis AI for Java is already there. Redis AI Pi is being developed. You can already use it, and we'll see a demo in a few minutes. Coming up, I have in the Redis AI example repo, there is an example using Node.js, even though there's no, it uses IO Redis. There's no specific client, but you will see that it's really simple. And we will see an example of that in this next slide, and then Go is another target, but we'll see how the community does. This is Node.js using async IO, so async await. We initialize a Redis client, we read a model in a script, and then we call model set, ImageNet model, TensorFlow, CPU, input node, output node, and then the model, which is the protocol buffer. And script set is the same thing. And when it's time to run, yeah, of course, you wouldn't initialize a new client for every run, but it was just to keep it compact. You can read an image, for example, resize it if you need it, and then set the tensor, passing it the buffer and the size. So the image usually is a 8-bit per channel. So here we have 4 channels. It's an image with an alpha channel at the end. So you have uint 8, height, width, 4 channels, and then the buffer. You can run the script, and then you can run the model on it. You can run the script again to do post-processing. There's an example. The example is in the repo. And then if you have to get, then you use await. So this looks sequential, but it's essentially done with promises, with nested, essentially nested callbacks. But it really looks sequential. So it's, even though there's no client library, it's really easy to use. Okay, so what advantages gives Redis AI to us today? So we keep the data local. So whatever computation you want to do, it happens in the same memory space. So everything is there. When you set the model on the GPU, the model is kept hot in the GPU. So when you interrogate again, there's no, of course, no reason to, like, no need to transfer it back, which is a costly operation. The stack is really short because you just need this. It runs everywhere Redis runs. You can use multiple frameworks. You can use it for multiple languages. We have optimizations in mind so that when you want to serve AI in production, you don't waste your compute that you have available. This is really important because to run models with low latency, you have to buy compute that is really expensive because most of the time you have a GPU and so on. So you want to saturate that. You want to use all possible resources by taking away everything, Python interpreter, whatever, and pack as much compute as possible so that it becomes cost effective to have a machine spitting out prediction all the time. So rather than having 1,000 containers, each with their own Python script running your inference, it's a lot better to pack all the compute in one Redis instance and maybe have it redundant and just don't have a proliferation of compute that is non-optimally used. It keeps models hot and has high availability. This is the Redis AI examples. One thing I would like to talk about is a roadmap, because right now we have a very basic set of functionalities, which probably are enough for a lot of applications. But we're taking it easy, and we're designing it in a way that this design will allow for more advanced things in the future. One is a command that DAG stands for Direct Acyclic Graph. So instead of this was triggered from a discussion on the Redis AI Slack. So if you have to run a script and then a model, and then a script, you have to first set the tensor, will hit key space, it will be replicated, only to run on the master node, for example. It runs, it writes the results, that will be replicated, and so on. And all these intermediates, you don't really need them, and you don't want to replicate them, because all you're interested in is getting a result. There are other use cases like the one I showed in, during the keynote, where you have a state that you want to persist. For example, the state of a conversation in a chatbot is something that maps one-to-one with the user because it catches where the conversation is. So you want to keep it within Redis. But for a lot of other use cases, you don't want to hit key space so much. So what we came up with is a design where we have volatile keys, and they're volatile because they have little wings. So it's easy to remember. Sorry about that. Which are variables that look like keys, behave like keys, but they're common local. So they only survive from here to here. So they never hit key space, they're never replicated. So here, for example, I set an input image, and then the output, sorry, I forgot inputs and outputs here. Sorry about that. And then the output is going to be called in volatile, which means that I can use it in the subsequent command, but it doesn't exist in Redis. So if another client will ask for volatile in, it will not get it because it's specific to this client. And so this model run will run on two volatile tensors, one for input and one for the output. And finally, only the last output will be saved. Well, this saves us some writing, but what's the big deal about this? Well, the big deal now is that if we also use tensor set as a volatile, then we can just send in the blob of data, run a model, and get the values or the blob out using all volatile keys. What is this? It's a read-only command. It doesn't change key space. So I can run it against replicas now. Okay? So if I have a large topology of a master replica installation, so I can set the model to the master, and then all the replicas are available for running models. That's a pretty cool thing, I think. Of course, the moment you write, then you cannot do it on the replica. And so what else you can do? So this DAG run is something that it's all or nothing. It writes out things, even if you write out to non-volatile, it will write it at the end, okay? It will wait until it's done to write things out in key space. And so this means that if anything fails, it will just, not be a problem for the others. The others won't see the results of this computation. And it's also nice because while the commands are blocking, so if I say model run, my client blocks, it will not go on, it will just be blocked. Redis doesn't block, the client blocks. So you can have a sequential programming style. But that prevents you to run multiple models in parallel. So if I say model run, model run, model run, the first run will block, will generate the outputs, the second, and so you cannot just have 3 GPUs and say run first model in one, run the second model on the second GPU, and so on. So that's a problem, right? It's I would have to use multiple clients, but that's kind of not optimal. But DAG run, if you use DAG run, it will analyze the DAG, the dependencies, and will figure out that these two can run in parallel. And so in the context of a single command, I can optimize the execution of the direct cyclic graph represented by the comments in here, and then fan out the computation, and then go back. And I think this is a nice design because it doesn't break the sequential nature of Redis, the ordered commands. It only breaks it within a command, so that you can do all the optimizations you want within here, but it doesn't impact the general flow of things that Redis has that makes Redis great. I'm thinking also about adding a purely asynchronous thing where it returns an ID, but I'm not entirely sure about that. I'm kind of resistant because it has some implications that I don't want to. Something that will come is integration with streams. Of course, this asynchronous thing could be obtained with streams, and streams are great for that. So why not having a stream in input in output? So Redis will know that that key is a stream, and instead of just getting the tensor, it will do something else. As soon as something arrives, it will run it and put the result in the output stream. We said Microsoft developed Onyx Runtime. It's kind of early stage, but it already supports Onyx. Sorry, one step back. Onyx is an interchange format for neural networks. It's like a standard, industry standards for representing neural network computations. And so we want to support that because this means that Redis AI will be able to run any neural network is supported by any framework. And also, it will support, as I was saying at the beginning, OnyxML, which is the same standard for machine learning models, and that scikit-learn has an exporter for that. And this will allow you to say, okay, I run a neural network, another, and then on the results I run another classifier, and so on. Auto batching, a lot of the runtime environments have automatic batching. So we will do something like analyzing the queue. We have a runtime that already did that, and then we switched to Redis AI, so we have to port that design here. So it analyzes the queue. It sees that in the queue, there are 3 operations against the same graph using tensors that have the same shape. So at that point, it checks. We can take this, make this go first, this other one, and run the batch. Why this is important? Because running a batch of computation, for example, matrix multiplication, it's faster if you do it by stacking all the tensors in the 0 dimension and doing a multiplication with a bigger tensor representing multiple samples, input samples, than doing it sequentially on all those samples. So instead of multiply, is stack, multiply, stack, unpack, and go. So this is a better use of resources. We think that this should happen. Well, you can already do it if a single client has multiple requests and sends the packed tensor and out. This is already working. But what if you can do the same thing with requests from multiple clients? It's a great use of compute resources, and we'll do that. Another feature we want to have, and then I'm done, is time to response. So computation in deep learning graphs is predictable. So I can predict how long it takes to perform operations because the graph is the same graph, more or less, all the time, except for exceptions. But the norm is this. So by analyzing the queue, I can know how long it will take for Redis to give me the answer, accounting for how many elements, how many requests I have in the queue, and how long my request will take. So I can decide to say, okay, no, you're too busy, I'm going to a different slave. Okay, other miscellaneous like a specialized info command for monitoring. So you can stick it into, I don't know, Prometheus and monitor the AI part. And dynamic loading on backends because you don't want to load all the CUDA kernels for TensorFlow if you're going to just use PyTorch. Okay, enterprise features will have advanced monitoring, some A/B testing. So I'm setting a graph at a key, and I'm saying, okay, you have 2 graphs now. Please run 5% of the time, run this new graph, 95% these other graphs, so I can monitor, and then I just switch and put another one in production, the other one in production, and then integration with other engines. The last thing we'll try, technically it's possible, but we don't want to pack too many features, is fine-tuning in Redis. So you have a pre-trained model, you want to just train the last layer on your data and not do it outside, but do it within Redis using script. It's possible, so we'll try that. So this is the roadmap. I'd like to thank Sharon Thomas, Rickito, and my historic business partner, Pietro Rota, and high school mate that worked a lot for this to happen. People at Redis Labs, they all contributed to Redis AI and are contributing. And my AI company, I founded 10 years ago, Aerobics. I would like to thank, at Aerobics we do engineering project using AI. And I'd like to thank these people that helped making Redis AI happen. The company that is launching in April is TensorWorks. We do infrastructure for data-defined software, so it's targeted to developers of the new era of software that learns from examples, because there's a need for development tools for this new type of software that is defined by data. So this is what we're going to do. We're looking for investors, so hit me up if you're interested. We'll have two projects. One is Redis AI, the other is Hangar. It's version control for tensor data, so think Git for tensors, because tensors are going to be your source code in data-defined software, so you have to manage it, versioning it as you version source code. So this is going to be released as open source mid-April. So hit me up. Coming up, we're a bit late, but Chris, we got in touch recently, Pipeline AI. I can let him talk about Pipeline AI. And thanks for joining us.
Yeah, man, thanks a lot. Yes, I don't know if I should yell or, like, this is so weird. Can you guys hear me okay? Okay. All right. So the cool thing here is you could actually log in later today or on your way home, not while driving, and go to community.pipeline.ai, and you could actually run this. So very similar to the JavaScript, but this is a Python demo. We have a Redis cluster set up already, and you could actually play with it and set the, oh, this is the Italian keyboard. I got it, okay. Yeah, he warned me beforehand. It's the Italian keyboard, but it's set to US, so it's even more confusing. So just go over to these notebooks and try it out. We don't have too much time for like a pipeline pitch or anything, but you can check out the website. But in here, when you log in, you'll get your own set of notebooks, and you could run your own sample data. How do I make this bigger? So we'll be using the ResNet 50. So this is actually one of the demos off of the Redis AI site. But I put this all into the notebook and got it running end to end, so you could play with it. So let me show you what's going on. We're going to do the imports here. We're going to connect to the Redis cluster. This is all running on Kubernetes. So we just use the internal Kubernetes DNS name, internal port that's not exposed to the public. Here, so this is just simple setting tensors and getting them out. So we could see one thing, if you are doing any sort of notebook stuff or any data science, you should always print out the shape. That's one tip, because oftentimes you're like multiplying matrices and setting tensors of different shape, and you can get yourself into big trouble here. So this is loading a blob here. All right, I'm just going to get to the good stuff. So what we're going to do is take some images. We're going to classify them. This particular data set is called the ImageNet data set. This is trained on 1,000 classes. So classes meaning dog, cat, penguins, all that kind of stuff. So as part of the prediction, so again, this is a pre-trained model. So we're not doing any training, we're just predicting. So we're going to pass in an image and then get a prediction. And one thing I was really surprised, actually, I was like putting this together last night. I didn't realize the add script and the run script. That's genius, because as we all probably know, predictions aren't just predicting against the model. There's pre-processing that has to happen on the inputs. Maybe it's taking JSON, converting it into a NumPy array. Then it makes the actual prediction using the model, and then that response has to get converted into something that can be used by the consuming microservice or UI. So the script stuff is super important to do pre-processing and post-processing. This is loading JSON, which is just all of the 1,000 classes. Here's the actual JSON itself. These are all the different classes: vine snake, I don't know what that is, night snake, boa constrictors, all kinds of weird stuff. So we've loaded those. Here's an example of what the ResNet 50 model looks like. Don't worry about it, it's pretty crazy. There's a lot of research that goes behind this. Here it's downloading the model because I think it's just over the 100 megabyte like GitHub limit. So we defer it. Now we're actually setting it. And here we're just using the Redis AI like execute command and then calling the same things that Luca was showing here. So inputs, outputs, giving it the model. So we're basically hydrating this model from disk and then sending it into Redis, which is pretty slick. And then these are these super important pre-processing. So this is actually one script that has 3 methods in it: pre-process, and post-process. You could put a bunch of methods in there and then reference them. So once you've set that script within Redis, you can now call those functions to do the specific image pre-processing and post-processing of the predictions. So let's set that. And then let's make these predictions directly within Redis. So we're loading the standard cat image right there. We're creating this blob tensor. This is actually one of the Redis AI classes. We're setting that tensor and then showing it just to see how cute it is. Yeah, I'm a cat fan. There's the tensor, so it's one single image, 224 by 224. That's the width and the height, and 3 channels, RGB, right? Green, red, green, blue. Here's just kind of a sample of what the data looks like. You don't really have to know too much about that, but always keep an eye on the shape of these tensors because that'll bite you. And then this is a sequence of those steps. Setting the tensor, we're running the script for the pre-processing, we're actually running that prediction, and then post-processing. And let's see, so we'll run this. Let's run it again because it takes a sec to warm up. So 0.88 seconds. Now, the prediction is an index within that JSON. That's why we had to load that JSON before. So let's look. So it's identifying this as specifically a tabby cat, and it would be under 281 here is the exact index for tabby cat. Let's do the same with guitar. It shows up as an acoustic guitar. That's index 402. And Salvatore, let's see what he comes up here. I did a talk last year here, and he was in the front row and left, like right before my talk, so now I'm going to get him back. Yeah, I don't know why he left. He went and started talking to someone. Barbershop, so, which is pretty accurate, I think. Okay, I think that's it, right? Okay, yeah, thanks, guys. Yeah, check out Pipeline.
Thank you.